This episode is brought to you by the Amp Hour audience. After 9 years of the Amp Hour, we're humbled that people still listen to the show. We also want to send a special thank you to all of the Patreon supporters who help us send mics to our guests and support our ongoing server costs. Supporting the show can take many forms, and we appreciate those who share the show with the world. We're doing our 2019 survey. Tell us what you like or don't, guest suggestions, and a bit about yourselves. We'll have a drawing for giveaways, but only survey respondents will be eligible. The survey closes on November 22nd, so get your info in before then. Thanks again for being a listener, and we hope to continue bringing you electronics discussions for a long time. This is the Amp Hour Podcast, released November 10th, 2019. Episode 466. An interview with Ryan Cousins. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
I'm Ryan Cousins, founder and CEO of Critical.
Welcome, Ryan. How you doing?
I'm doing well, Chris. How about yourself?
Good. It's been a while since we've seen each other. We used to hang out at in San Francisco at the Hardware Didactic Galactic, or Hardware Developer Didactic Galactics, I suppose.
I know. It's always can always be somewhat concerning when you start seeing some of the familiar faces disappear for a while. Because I mean, you go to one hardware event around here, and you see everyone at all the same events. So it's
right. Yeah, it's interesting. Like the community there, and it was kind of like that. There weren't like a ton of hardware events, surprisingly, given Bay Area and stuff like that. But it would be a lot of familiar faces, and is it a smaller community than I expect, or is it just a smaller social community than I expect, given that it's like in San Francisco proper?
I mean, San Francisco itself is relatively active in hardware, I would say. I'm not necessarily surprised at the volume of hardware entrepreneurs, startups, communities, just given it's hardware and it's hard, so most people just aren't really interested in doing it.
Yeah, right. Right. Given compared to the payout and the the potential upside of a software career in the Bay Area, I'm sure it's a little bit better, right?
Exactly. Yeah. You have the magic just of software, and instantly you're like an overnight billionaire. So,
right.
Not necessarily how it works with hardware.
Right. Yeah, that's right. In that vein, I mean, you chose to do the hardware route in the Bay Area, so. First off, what is Critical, and then how did you get to the path of choosing to do hardware in the Bay Area?
Yeah, well, quick background on Critical. Started the company a few years back with two co-founders. We primarily focus on safety critical and mission critical applications, but have also gotten a fair amount of exposure in recent years to a lot of video processing and encoding kind of stuff. We're primarily an embedded systems company. So we have our core platform. It's called Snickerdoodle. So it's a little less intimidating, but we, focus on providing complete hardware, software, IP, manufacturing, all those kind of solutions to companies and customers who are looking to develop new products in all sorts of different areas, from robotics to consumer retail applications. It's our actual commercial products are kind of all over the map, but we use our core platform Snickerdoodle to build custom systems around it for people developing these commercial products and try and help them get from prototype to production as quickly and as cost effectively as possible. So we've San Francisco is a challenging place, I would say, to run a hardware business. For as much talk as there is about hardware funding in Silicon Valley, that has mostly eluded us to date for a variety of reasons.
Right. You guys aren't far enough south. That's the problem.
Yeah, exactly. Apparently. Yeah. Yeah, it's been good. It's helpful to have at least some semblance of a hardware community around. I'm not sure how much of our success or lack of success could be really attributed to our physical location. other than everything just generally being more expensive here, of course.
Yeah, the DigiKey orders are the same price, but the place where you order them from, the price goes up a little bit.
Exactly, that's right.
Yeah, so let's talk about the Snickerdoodle real quick, because that's going to be a core focus of what we talk about here. You'd mentioned video, you'd mentioned embedded software IP and stuff like that, and I think once you explain what this thing is, people understand how it could be all these things in one package.
Yeah, sure. So we built this product kind of out of necessity, you could say. My co-founders and I, we were working in primarily the medical field before this, doing a lot of system development, primarily in the area of like mechatronic systems, so real-time motor control, sensor integration, things like that. And what we found is we were doing a lot of the same stuff over and over again for different customers. So everyone would start with a clean slate. You have to architect kind of the main control and integration system for each individual project and customer. And as time went on, we just saw the same patterns over and over. So we kind of figured, we saw this kind of hole in the market between the super low end cheap stuff that depending on the application, most likely not going to use in a commercial product like Raspberry Pis and Arduinos and stuff like that. And then on the other end of the spectrum are these pretty hardcore systems that are a lot of the time incompatible from either an actual usability standpoint or final cost of goods or whatever it is. It might be like thousands of dollars for a single development platform, and then after you're done with that, you have to figure out how you're going to turn it into a real product. So we basically set out to have this fill in that gap where we have a very versatile hardware platform that can scale very easily, and that can basically get you from an idea to the market as quickly as possible, without having to deal with all the headaches of this super hardcore integration piece, like down to the silicon level. So we settled on an architecture that involves an FPGA SoC. So it's a field programmable gate array. And I can explain that a little bit, but effectively, it's a software reconfigurable piece of silicon with a couple of ARM processors, ARM cores built into the system on chip. And that built around that, we have Wi-Fi connectivity, memory, flash storage, some supervisory microcontroller stuff for power management, and other onboard peripherals. And what we wanted to do is give people as blank of a slate as possible to build on top of, while still not making them start from complete scratch, both from a hardware and software standpoint. So kind of give them a baseline saying, hey, here's all the support and integration that you don't have to spend a bunch of time on. Now you can really focus on what your value add is, so your specific application. So having a whole bunch of different inputs and outputs that are totally software customizable or reconfigurable allows you to do, that kind of is what enables all these different applications, from robotics, sensor fusion, remote sensing, those types of applications, all the way to networking, high bandwidth applications like video processing and encoding, computer vision. It sort of runs the gambit. You're never really. We always saw this limitation with a lot of the kind of more traditional, microprocessor, microcontroller architectures, where you would run into this issue where you would get so far along in your system development, your product development, and then you might have either some feature creep or something that comes up that you just have to be able to accommodate that you didn't plan for, and then you might have to go back and select a completely different part or architecture and start from scratch, or you throw out a lot of the work that you did. So we're trying to eliminate that burden as well.
Yeah, so you guys pretty much are like, it seems like the MO is kind of like just overspec it from the beginning, right? You're in robotics, you're in video, you're in networking, you're going to need a lot of juice. Here's all the juice you can get right now, and in a pluggable form factor, and it's flexible, it's configurable, it's that kind of thing.
Exactly, and I can't think of a single project in the past where we've like overestimated the amount of stuff we're gonna have to connect to to a
Right.
processor or
Right.
microcontroller.
Yeah.
Every
Right.
time it's like, oh yeah, we should have actually added like a reset signal here, some enable signal there,
This
or
this
you
client
know,
is perfectly happy from day one.
yeah,
What else could they
exactly.
possibly need?
Yes, yeah.
They are so content. Yeah. Yeah, I know those feelings. Yeah, I mean, you're right, and I think even the the reduced risk side. I think there's a lot of risk here, and this is something I want to talk about. There's risk in the fact that it is overspec and it is more complicated. I think you guys work against, you work towards making that less so. But like the risk factor of like, hey, you throw this thing in, pretty much any pin can be almost anything. Now, of course, that's never true 100%, but like
Mm.
being able to like, so from my personal perspective, oh crap, I hooked this pin up to I hooked TX and RX up wrong. In an
Mhm.
FPGA, who cares? TX is
Yeah.
RX, RX is
Yep.
TX, who cares? It's no big deal.
That's
Like
right.
that is that saves you what, even on a fast board spin, what, 3 days, 4 days, whatever, saves you thousands of dollars, saves you a ton of time, and that could really be valuable from a development perspective.
I mean, yeah, it's crazy. I mean, especially when you're talking about hardware, like you're saying, when there's not only, I mean, there's so many costs both that are tangible and real dollars, but also to a certain extent intangible. The amount of time lost with new spins and whatever else, lead times for parts. I mean, literally, like 2 days ago, working on a new project that's based on Snickerdoodle, and we got the new hardware in, had this whole hardware definition file put together that basically configures all the different I/O coming out from our module to this baseboard, this custom baseboard we're working on, and realized the wires, quote unquote, were hooked up wrong.
Yeah.
But I mean, within an hour, it was all fixed and it all worked. So I mean,
Right.
it's you're never, unless you're gonna get the Dremel tool out and cut like 30 traces on a board and have a pound of magnet wire strapped all over the board, then I mean, there's just no way you're gonna be able to address.
We're looking at you, Greg Davil. We know where you are. People who follow me on Twitter know what we're talking about. Yeah. Yeah, and that makes it, and then that's one, right? I think that's the other thing is like from a scaling perspective, right? So now I've been in the place where I messed up a board, right? I bodge it, and I've got a bunch of magnet wire going all over the place. No big deal, right? That's one. I bought 5. I need to make 5 for proofs of concept so I can get them to work together or whatever like that. Making one is something I don't do anymore. I make a bunch, and if I mess up one, then I have to fix that one. If I mess up 5, I have to fix all 5, and then your time scales linearly, right? And it's like you have to go and bodge 5, and then you have a bunch of variability between them. And this one's wire broke, but this one's fine, and I got to track that. It's just
Oh yeah,
there's just a ton of risk.
No, absolutely. And I mean, I think, and obviously when you're doing embedded system development, I mean, every software engineer needs a piece of hardware. And yeah, if not all of those pieces of hardware have the same rework performed, or, you cut a trace and like now you have, some signal line going to ground and you can't see it, even under a microscope because some internal copper layers mashed against another. I mean, there's all sorts of, there's so many different problems with that. And not to mention, a lot of times, even if it's like, say, your second prototype run, you do want like at least some certain high level of confidence that if you're planning to go to production with your very next hardware spin, that all these issues are actually addressed. And if you're looking at a video bus that now you have to completely reroute, and then like you double check it a bunch of times and like really hope that you didn't miss anything, well, you could have a bunch of dead boards, next time they come off the line. So being able to add that extra layer of validations, a big time and money saver as well.
Sure. Okay, so let's pull it all forward, because I've been accused, or I've accused myself at least, of kind of waiting to the end to put the price tag on it. Let's say right up front, how much is a Snickerdoodle board? A Snickerdoodle 1 and a Snickerdoodle Black.
Yes, so we do have two low end and a high end product. So the Snickerdoodle 1 you can get on Mauser right now for $115. The Snickerdoodle Black, the higher end version, upgraded FPGA, radio, memory, all that good stuff, is $245. Okay. And then we have a couple other baseboards that the module can plug into. There's kind of two different use cases. There's sort of the benchtop standalone Snickerdoodle, which you can, like the Snickerdoodle 1, for example, you can buy with you just plug some wires into it and start hacking some stuff together. We also have what we call the Pi Smasher baseboard, a la Raspberry Pi, that has HDMI input and output, a couple of gigabit Ethernet ports, a bunch of USB, FPGA I/O. This is $245 as well, so that's kind of a cool and audio input and output and headset. So it's kind of a cool audio, video, networking kind of development platform. This just basically extends the Snickerdoodle, and then there's a separate like breakout board for just kind of the same thing, just breaking out a bunch of I/O.
And so I wanted to do this because I think right now someone just threw up their hands like, oh my God, a Raspberry Pi is only $35. How is it so much? Mm-hmm. But I think because we're talking about the risk factor and the integration factors and everything else, that's actually what I wanted to talk about here, because like, what is the real cost of implementing like Linux systems or highly flexible systems and then going to production with them, right? So like I imagine, and you can correct me if I'm wrong here, I imagine that your core customer is someone doing like 10 to 100 of something, at least at the beginning. Is that about right?
So, I mean, so in terms of commercial applications, it's from a prototyping standpoint, yes. I mean, pretty much we start almost every single building, somewhere, but depending on the board size and a bunch of other factors, between 10 and 20 units. We might like run 100 PCBs and stuff 10 or 20 of them, kind of thing. Yeah. The typical volumes for the applications we're working with range from, say, like the hundreds a year to give or take like 10,000 units a year.
Okay.
Beyond that, which is like a pretty large subset of applications. It's not necessarily some random consumer product that you want to sell 10 million of, in which case, you're
why are you using a Zinc?
Exactly. Like you're going to build some ASIC or do whatever crazy custom thing you have going on. But just given the amount of time and, engineering effort it takes to actually get all of this stuff working. We can just say from experience that it's not just some, you have somebody come in and say, yeah, I know Linux, I'll figure out this Zinc thing, whatever. It's got ARM on it. It's like, you just give me I'll design this hardware from scratch and we'll figure it out. Right. I mean,
was that A9? A9? Yeah, I've done those. Okay, cool.
Exactly. Yeah. I mean, it's not exactly that easy. I wouldn't say, and plus there's the hardware validation piece, supply chain. It's you have to manage. There's a few different vendors you're going to introduce. I mean, there's also some cost savings you can get from going from a modular solution that's like very dense, 14 layer board, and maybe your application board only has 6 or 8 layers. That could like cut your PCB cost in half. So there's all these different kind of considerations. But I mean, I think ultimately, not obviously this thing, while it can do a lot, I'm never gonna. I'd just be lying to people if I said this is like the right solution for every application. That doesn't exist in the first place.
You're going to see this on the next iPhone, guys. Come on.
Exactly.
Pluggable board into your phone. Come on. It's just all you need is a battery and a screen.
That's right. Well, and obviously on the flip side, I mean, if you just need to like flick a couple lights on and off and hook a button and a thermistor or something up to something, then just buy a Raspberry Pi. I'm not going to sit here and tell you need an FPGA to blink an LED.
I was going to say less than that, but yeah, okay.
But I mean, people just buy Raspberry Pis because they have like 5 sitting around their desk or whatever. Yeah. But I mean, this is, if you're doing something that has, some higher level of motor control, a lot of more sensor integration, video processing, like I mentioned, is a big one. Networking capabilities. There's a very, a lot of it's like a kind of industrial IoT, I guess you could call it, type stuff. But it's kind of a more like robust solution, and it is designed to scale quickly from prototype to production.
Yeah. Well, and I think so. Another thing I wanted to bring up, you mentioned supply chain stuff, and I think you were saying it from the, sourcing. If I want to go out and source a bunch of Zinc chips myself, I could go on DigiKey or whatever, but like that's a lot of support circuitry and stuff like that. That's kind of already encapsulated here. Another piece though, and something I've dealt with, is like, you're not supposed to buy Raspberry Pis like this. I mean, yeah, sure, people do, and I know they have the module for like the the compute module and stuff like that, but it's just not really what it's meant for. And
Yeah.
it's a supply chain risk in its own right. Now, I think there's replacement boards that have been out there that are, basically are matching the interface, like the 40-pin header, but yeah, they're not meant to be like that. And this is meant as a plug-in module. And from that perspective, I think there's some power in that.
Yeah, no, absolutely. I mean, we even have like on our website a SOM lifecycle agreement, signed by yours truly, that guarantees.
Industrial people love those things, man.
Yeah, well, it's nice because like it basically because a lot of these applications are industrial. I mean, even some defense applications. Some of these things where.
I went 10 years. I went 20 years, man. Yeah.
Yeah, absolutely. Yeah. And Xilinx knows that. I mean, Xilinx isn't Qualcomm. Qualcomm, throws a chipset in the garbage every year. Yeah, exactly. Yeah. They've been building Xinx for, a decade plus, and they're probably going to be building for the next 30 years because they're in a bunch of equipment that they need to be able to source for it. Yeah.
It's been a decade already on the Xinx?
I'd have to look back exactly, but probably about that. Yeah.
How long have you guys been around? I guess that's a good starting place.
So we started the company about 5 years ago.
Okay.
Really dove deep into it about 4 years ago. So I've been essentially selling the product for 4 years.
Yeah.
So yeah, I mean, it's a very, very mature hardware platform, and it's not. I mean, every time Xilinx tries to phase out a some part, they get some massive backlash, and then they end up supporting it for the next 10 years. It's kind of a nature of the industry kind of thing.
Oh, got it. So like even like the older parts, not necessarily the Xinx you're saying, but like the Spartan 1 or Spartan 2 or something like that?
Spartan's a perfect example. They just released, I mean, I don't even know how old the Spartan line is at this point, but they just released a Spartan 7 last year. So that part's not going anywhere.
So you've signed this agreement. Xilinx is pretty good with this stuff. I mean, is the Xinx starting to get a little long in the tooth, or is it just like I guess that's kind of the interesting thing about industrial stuff too. It's usually not super mission critical, but it sounds like this thing can still crank through a lot of video and high demand things anyways. It's not like it's running out of room, right?
Yeah. For whatever reason, we've seen probably the biggest area of interest for us has been in the video space. A lot of video encoding stuff and processing. It does. At least to the specific part we're using, we do start to get kind of pushing up against the edge of what the part's capable of technically. But they now have Zynq UltraScale, which is the latest and greatest thing, and of course Xilinx has already announced the next generation of their SoCs, which are even more hardcore, of course. Ultimately, we'll be going in the direction of UltraScale. At least that's the tentative plan. Once we, have the resources and everything and to do that.
Yeah, right.
But
it's not a small undertaking to be like, oh yeah, let's just upend our platform.
Exactly.
We're also supporting all of our customers for 20 years.
Well, yeah, and for the same reason that that there is value in having a platform like ours. It isn't, to your point, not just something you turn around, spin around on a weekend and say, oh yeah, that was a piece of cake.
Yeah, exactly.
So it's a big undertaking.
Yeah, I imagine that if from a company perspective, if you say you scale from 2 boards to 3. Right, you effectively need to keep supporting the first 2, and that means you probably have to hire someone, right? You have to have someone work on the new stuff and someone to still be working on the old stuff. Someone who used to work on old stuff,
for sure.
There's a job there, like you got to keep things going.
Yeah, and I think that's definitely one of the challenges, just in general. I mean, we kind of took a slightly, well, I don't know about slightly, but a different approach than a lot of hardware companies do, and that a lot of our kind of strategy was built around this having a broader community of developers, not that they're necessarily self-supporting, but that can help each other to a certain extent, very similar to like BeagleBone, Raspberry Pi, or Arduino, all that kind of stuff. But of course, then there's the added layer of having commercial customers using the stuff. So that's been one of the more challenging pieces, is keeping the overall community engaged and being able to provide support for both paying and non-paying customers. I mean, I go on and on about the trials and tribulations of forming an embedded development platform community. that's a
Yeah,
undertaking
right.
in and of itself. But yeah, support's definitely a big underrated piece, I would say, of doing something like this.
Yeah, and I'd actually love to talk about that from kind of the trying to get the numbers of a free community, but then the payment of the paid community, that kind of thing. Before we do that, though, I'm curious because you said video is a big piece of what people are targeting your board at. Um, what what are the options if you're not going with something like the Snickerdoodle? Like that you want flexible fabric, you want to write your own encoders, or you're going to be using FPGA. Is like the only real step to like start on a existing platform, like the Digilent board or a Xilinx dev board from Avnet or whatever, and then just go straight to a custom board? Is there any other midway between, or is it just you guys?
Well, I mean, so like Avnet, has modules as well. There are other Zinc modules out there, of course, that
Okay,
of course, as you can imagine, range from the relatively affordable to the insane in terms of pricing and
yeah,
all that. But I think yeah, it's a lot of those do take on the form of a single board computer style, like the Z board. It's whatever it is, $500 or something like that, for the same core part, the same SoC we're using on the $250 Snickerdoodle Black. But it has it's like as if they integrated like more or less like what we did in a modular form. So we took this module, plugged it into what we have as the Pi Smasher, and created this like double board computer as opposed to a single board computer kind of thing. Whereas they just took one single SBC and put everything in the kitchen sink on it that you could sort of bolt to it. So it's different approaches. Of course, the challenge then going into production is, well, now you have to integrate all that hardware into a totally custom design, which is, then it
right.
comes
Yeah,
to
and
all
that's really what I'm getting at, is that like you guys at least have a step where you could say, all right, you don't want to go to a full custom design yet, no big deal. Put our headers on there, and then the Snickerdoodle can plug into your board. The customer's base daughter, or sorry,
baseboard or daughter board.
words are hard today. Yeah. The baseboard here today. So you have your processing board, which is the Snickerdoodle. It plugs down onto a simpler baseboard, right? And you basically get to skip some production steps before going to that 14-layer board, like you mentioned.
Yeah, exactly.
And
I mean,
custom.
and like I said, we've seen a lot of customers where it makes sense to just, use a Snickerdoodle in production. Granted, like I said, if you're building 100,000 of something, maybe not, or we can talk about that. but I mean, realistically, there's so much development cost and time that you have to really weigh, what's the life cycle of your product, what extra margin are you trying to squeeze out by getting rid of this module, because you still have to buy all the parts that are on there, for the most part, other than maybe some connectors and a couple things. But there's obviously a lot of different considerations.
Your customers get access to then your higher volume pricing with a Xilinx or someone like that too.
That's right.
Which anyone who ever looked at a FPGA on a DigiKey or a Mauser before, you're like, oh my god,
yeah.
Single piece price is like $150 for a chip. What is going on here?
Yeah. Yeah, it's pretty crazy.
It's the steepness of the single piece price curve is a little steeper on FPGAs for some reason.
Yeah,
probably because just the holding cost and how often people need it is just low. You don't need. Most people aren't buying in the single quantities unless they're really needing it.
And there's some weird considerations to that as well. That you can buy Xilinx parts on, say, like DigiKey and Mauser, but like in the case of Xilinx, Avnet is really the only like authorized volume distributor for their parts. And part of that has to do with export compliance and some other stuff that makes it just easier to manage if you're going through a single vendor. So so that's like got its own, layer of, I don't know, complexity, if you want to call it that. Just make it. It's just another piece of the supply chain that just I can tell everybody's listening, like, you don't want to deal with any of that. That's like,
Yeah,
I mean,
yeah.
it's like a necessary part of this job, but it's probably the worst, like most,
Yeah.
soul sucking part of the entire experience.
Well, that's actually a good segue into. So let's hear about how this whole thing went for Critical, the company, because you guys had to do all this stuff and you had to deal with it. And you had to deal with crowdfunding and everything else. So how did it go? Sounds like you're just a proponent of starting a FPGA based embedded board company.
Oh yeah, I recommend it to everyone I come across. Yeah.
Yeah, right.
Yeah.
Grandma, hello, I've got a new idea for you.
Yeah. It went. I'll put it that way. The crowdfunding experience was an interesting one, to say the least. From one standpoint, it's really obviously gotten us to where we are today, for better or for worse. We had.
And when was the crowdfunding, and what did you run it on?
So it was almost exactly 4 years ago when we first launched the campaign. We ran it on Crowd Supply, and actually, it's nice because Crowd Supply also can help you transition into distribution pretty well. I'd recommend checking them out for sure if you're looking for if you're interested in doing some sort of open source or development platform kind of project. They're big in the open hardware community. They now stock our products, so they're a manufacturer or a distribution center for us now, which has been obviously helpful. But there's really no getting around, regardless of the platform. There's no real getting around the inherent challenges of crowdfunding. We
haven't talked about that at all in the Amp Hour ever.
Yeah,
so.
I bet. Yeah, it's a very it can be a very frustrating and disheartening experience. Not even necessarily from, say, like you go and like you go out with your sign on the street and start, and then you just get annoyed when nobody's just flooding through your door trying to get your product.
Right.
That's just inherent to any business, but it's really tough, I think, because we had a pretty good feel, being people who actually would use our product to begin with. We had a pretty good feel for the types of people in the audience that would be interested in something like this. But just and probably rightfully so, the massive amount of skepticism that people have for crowdfunding projects, because people have seen so many of these things fail, so much money, just thrown down the drain. Honestly, like, if I had to be perfectly honest, our project should have failed. I guess you could say in some cases,
too honest.
It's sort of
too honest, Ryan.
I guess you could say in some cases it kind of did, other than the fact that now we selling through distribution and all that kind of stuff. We have a functional piece of hardware, a few pieces of hardware, and community, and some commercial customers, and whatever else. So kind of like failed our way to success somehow. But it's interesting. I was honestly surprised at how much negativity there was just in general around the whole concept of crowdfunding campaign. And as a creator, you're really putting yourself out there when you launch a campaign. You're taking all of the risk. The incremental risk for somebody to spend $50 or $100 for something that may or may not ever show up. Obviously, you don't want to go through life spending your money on a bunch of random stuff like that. Some people do,
right,
I guess.
Right.
But you have to have a lot of disposable income if, like, you have a 20% chance of every product you're buying actually showing up at your door.
Right.
But I was just surprised that that risk is just so much lower than the personal, professional, financial, technical, whatever, all these different risks that you're taking on as a creator. To ultimately, obviously, you're getting some hopefully long-term benefit out of that yourself, but providing something new for creators like that to use. I don't know. I was like surprised and frustrated. I'm sure you can go back through my various message board, postings and different articles and stuff from 4 years ago, and probably hear the the anger being typed like through the keyboard under the screen. Just like, why?
I was just actually, I was basically curiously searching through the Google right now. I was like, oh shit, were we negative about this? And then actually, no, I found a positive thing. I actually, when Clint Cole was on the show back, this is a long time ago now. It was at 302 rather. He was the former president of Digilant. I actually mentioned the Snickerdoodle to him, and the notes that I put in the show note was that why care about FPGAs in general? Most people don't understand how they can be useful. Chris mentioned the Snickerdoodle enabling high end systems, and basically that we were commiserating that people don't really get it. People don't get FPGAs most of the time. Like they see, like, you can maybe tell them about the applications and like interested in drones and video and all this other stuff, and then you tell them like, oh yeah, and you can do Verilog and you can compile systems and you can pay $250 for a circuit board, and people are like, oh wait a second, I thought I was going to be able to make a media center. That's what I was doing. Supposed to do with my Raspberry Pi, and yeah, it's a lot of freaking work, like these are not simple systems.
Yeah, but, and I mean, you definitely hit the nail on the head. I mean, an FPGA's versatility is also what makes it so challenging to convey what the hell people do with it. I mean, because when I just like put some widget in front of you and tell you this can do anything you want it to do, like that like makes you just more confused than if you've never seen it before, So it's
well, I mean, and engineers love constraint systems, and with an unbounded system like that, it becomes difficult to envision. Like, okay, well, what do I do with it? I don't get it.
That's right. Yeah, and honestly, we like, if we didn't have the Pi Smasher, I don't know if we'd have any customers. It's kind of a weird thing because so many people have looked at that and said, like, this isn't really what we're not trying to like replicate this, like what you built, obviously, but this is like, this at least shows us what we can kind of connect to this thing and what we can do with it. So, oh, you have video input and output. Oh, I have this like video encoding box that I want to build. Or, you have a couple gigabit Ethernet connections to this thing. Yeah, I want to run like some gigabit Ethernet into like some programmable logic, do some like, packet reordering or sniffing or whatever you're doing, and put that into some industrial application or whatever. So it's like once you start to get closer and closer to the end applications, people of course start to get it more and more. But doing that with some random development platform isn't necessarily always easy.
I've always wondered. I have no hard data here as well, but like I mentioned the people doing a media server. I am one of those people. I thought I was going to do a media server with like a Raspberry Pi or something like that. How many are sitting in drawers all over the world? I've definitely mentioned this before. It's like, I think that is a lot of what builds the pyramid of supporting hardware and supporting interesting things, that enable other things in the future. So
yeah, I mean,
God bless them.
No, 100%. I mean, the bottom line is like, this stuff is hard. Like, I mean, I don't care if you're using an FPGA or not. I mean, maybe writing a few lines of Python code is something pretty much anyone can get started with in like a couple hours. But I mean, building like commercially viable products, or maybe not even commercially viable, but something that's like relatively sophisticated.
Sure. Yeah, just high complexity industrial products or high complexity robotics and stuff like that. Yeah, it's a big deal. Yeah. So, and I think that is hard, because then you were saying that you and your co-founders understood the struggle and what problem you were solving, right? In the sourcing and the the getting hardware in front of people, but it is hard to convey that if you have 100 people and none of them have one of them has ever taken a thing to production, and 5 of them know what this board is, and 100 of them are interested at least marginally in what the end application is. It's like, it's hard to say to someone, well, in about 3 years, when you really want to take this to production, it's going to suck, and we're saving you that up front.
Yeah. But, well, no, I mean, it's true. It's funny because you mentioned some of these issues around FPGAs, which have been present ever since FPGAs were invented, which is they're extremely open-ended and pretty complex to use. And of course, one of our big visions with Snickerdoodle was eliminating a lot of that. Nobody wants to sit around. I mean, well, I shouldn't say nobody. I don't want to we love FPGA engineers. So a lot of them just love writing VHDL and Verilog, 8 hours a day, which is great. But the vast majority of software developers don't know what VHDL stands for, and they don't care to really learn what it stands for. So it's let alone learning a completely new paradigm and language and all the rest of that. So I think part of our vision was to eliminate a huge part of that barrier to entry, and make the actual integration of these programmable logic systems much easier, like much more kind of friendly to your average software systems developer. Of course, well laid plans kind of thing. Our ideas of grants are basically proven some traction with a crowdfunding campaign and going and raising a bunch of money so we could build out some big platform for making everyone's lives easier. Didn't exactly go according to plan,
right.
but do what you can.
Yeah. Well, but now you don't have to deal with VCs all the time either.
That's true. Yeah, there's some upside, I suppose.
Yeah, right. I mean, so obviously there's the value. We kind of talked through the value add on the supply side of things. Obviously there's a module that someone could buy off the shelf, design a baseboard, plug it into it, get a lot of flexible processing in there. That sounds great. That's definitely useful. You've mentioned platform side of things though, and so what does that look like? I mean, are people using the Xilinx tools and just kind of building the system like anyone would with a normal dev board, or is there some other thing that Critical and with a Snickerdoodle is like there's like a software layer that you said you're trying to make easier?
Yeah. So right we out of the gate, I mean, and this is another one of those things where I can't say that we would do it the same way a second time, but one of the major things that we did from day one was be able to support Ubuntu Linux out of the box. So you get a fully supported FPGA platform that's running Ubuntu, and then you can of course build on top of that using the Xilinx tools and all the rest of it. What we're working on is getting the actual IP integration side much more streamlined and simplified for people. And in addition to that,
like an app store for digital, or rather for hardware layer type things.
Effectively, yeah. I mean, it's definitely. That's one of the biggest pain points, obviously, you see is even if there's commercial IP available for a specific thing you want to do, getting that, buying that is usually extremely expensive, and you're
talking to lawyers, and you're signing very big contracts.
Oh, it's totally insane. Yeah, minimum. I mean, there's a few pieces of IP for a few $100 that you can buy, but like generally speaking, you're like 5 to 6 figures, and not counting any of that legal overhead or anything. And then you actually have to get whatever it is to work on your hardware, which is like
that's right. Yes.
Might cost you at the same amount or double or quadruple what you paid for the IP in the first place.
Let's talk about building custom Yocto systems.
Oh yeah, and it's ridiculous. Yeah, exactly. Because then you have the whole like operating system integration side of that thing. I mean, I mean, that's ultimately like we've kind of chipped away at that already, just in terms of getting something usable out of the box. You have a supported thing. It's like a closed system. You kind of know what you're getting, as opposed to just building everything from scratch, which is just a nightmare.
Right.
But
that is the thing that I always think about is like, okay, so I have written some awesome Verilog. I've got it tested. I've simulated. I got it installed. It's hooked into my bus and it's talking to my processor and everything's great. It's like, oh, I got to go write a driver now.
Yeah. Oh yeah.
like Linux doesn't know what that is. You got to go like write some code now. You've got a processor. It's got to talk to the hardware. Like that's a thing.
Yeah. No. Honestly, Linux has been like. I mean, it's. You kind of course, like as with everything, there's pros and cons, but Linux has been probably the biggest drain on our resources of anything we've ever done. I mean, it's like. It was like basically getting Linux to run properly on this thing was more effort than like probably designing the hardware was. I mean, it's just. Wow. I mean, like in hindsight, of course, we wanted to provide like a platform that would be more familiar to your kind of average software developer, which is how we eventually settled on Ubuntu. There's all sorts of, Yocto or PetaLinux and all these other things that are probably more readily supported by Xilinx, but like nobody cares about any of those really. I mean, to just be perfectly honest about it,
if you're trying to target software people and you want to like apt-get install something, it's like, you're not doing that in Yocto. You're going to, fetch the things and build all your software yourself.
Exactly.
You got to go.
Yeah. Which is, it's good and bad. I mean, now we have this super familiar platform, but now you're maintaining Ubuntu on an embedded platform, which is just a complete nightmare.
Every 6 months.
Exactly. Yeah.
April and October, you're doing more work.
Oh yeah, for sure.
If not before that, Yeah. So the Linux side of things, what is the hard part of that? And what are other systems? I wanted to compare and contrast again for like what you guys are offering versus what other things that are out there, right? So like you'd mentioned the Z board and things like that. Is the Z board running Linux, or is it more bare metal, or like what are available to people if they're like, oh, I need flexible fabric? Is it the go build your own Yocto?
Generally speaking, that's the impression I get. So the Zinc book, that's literally the name of it. It was originally written for one of these Avnet boards, but it's of course applicable to any Zinc platform. Is a really good resource. We've interacted quite a bit with some of the professors at University of Strathclyde who originally wrote it. And so that's kind of an interesting place. They have a lot of good resources for doing like bare metal stuff, which is like you want something to actually work, and you're not gonna sit and the rebuilding device trees and kernel modules and like drivers and like this 600 other things that you need to integrate with Linux. This isn't supported anymore. Now you have a different version of this. It doesn't work with that. So I mean, it's just so that that's a really that's an interesting approach. Of course, that doesn't necessarily work for everything. Some there. I don't want to like just totally poo-poo Linux and make it sound like it has zero value, because once you get into wireless and networking and stuff like that,
just displays. I mean, like displays are crazy. It's like, oh, you want to go write make a custom, Qt based display, in, FreeRTOS or something like that. Ugh.
Yeah. Which
it happens, but it's not easy.
That's right. Yeah, and it's pretty hard to justify. It's much easier for like a company, so to speak, to justify that kind of stuff because there's like a commercial demand for it, or at least ideally. So i.e., somebody's paying for it. It's part of the idea, at least with Linux, is, this is all just, free open source, we're going to get this thing working and in a hackable state.
Right. And in theory, it just works. Now, obviously that is a very big asterisk on the end of that theory. But I think from a, how you've talked about your customers, especially, starting from a team of one, if I think about myself, how I would go and design an FPGA board, first off, I have no idea where to start. But if I went and grabbed like a Snickerdoodle, I could design a baseboard for it, I think.
Yeah.
And I bet I could go and roll that into in a system that has, I need Linux, I need a display. I could put all that stuff. I could hook that into the connector bus.
Yeah.
And then start to drive it with this device tree with the Linux-based thing that has a device tree that needs to talk to everything, blah blah blah.
Yeah, exactly. When you're starting from an already supported platform, in some state, like, I mean, you saved yourself from going from having no idea what to do to, okay, well, I can look it up, on some random Linux forums and figure out how to actually get this thing to work.
Right. You're not out in the dark, like reading man pages,
That's right. Yeah. And maybe all you have to do to build like your little, like your little rover, drone, or whatever it is that you're doing is just the electrical engineering side of that. It's like, you need some power supply stuff, some connectors and some other random things that are going to be bolted to whatever baseboard that you could just like,
or you call a great electrical engineering consultant like myself, and
that's right.
Sorry, I just had a little plug in there. But yeah, I mean, like a software person or software focused team, you could do the hardware once effectively, and then the value add for that team is adding software layers, adding more and more features on the software side.
Yeah,
and so it really enables like software people, like you're saying.
For sure. Yeah. And I guess to just follow on to that, one thing that it's kind of hard to figure out how much interest or how much this is really being used. I think it's pretty big in education, but there's a kind of relatively new framework called Pynq. It's like it's like Zinc, ZYNQ, but with a P.
Yeah.
PONQ. It's like a Python for FPGAs, generally speaking, which is kind of interesting. Like I said, they use it a lot for education, just because it kind of lowers that barrier to entry. It's not something that
you think you have a 12-week course or whatever. And you're like, okay, well, we're going to start at transistor level. And we need to build a Linux-based system on custom hardware
exactly.
by the end.
Yeah, right.
Like,
shit. Yeah, usually that's spread over like 4 years of education, rather than like 14 weeks or whatever. But no, I mean, it's
right.
Yeah,
and then someone's going like, and I can't have spaces in Python. Is that right? That's where I should be starting.
Yeah, exactly. Yeah. So there's some interesting frameworks like that people are kind of come up with, but yeah, I mean, none of it's easy. You try and abstract it as much as you can without abstracting it too much, because then you if you abstract it too much, then you take away the whole benefit to having this reconfigurable hardware in the first place.
Right, exactly. At that point, why not just build it on just any other ARM processor, that kind of thing. So, yeah. Well, let's abstract a little bit here from like what you were saying. Let's hear some of your customer story. You don't have to tell us who the customers are or what their specific things are, but how are they using it in that custom way? Because I think that's another thing. Like we're trying to make something. We're trying to talk about a thing that is pretty abstract on its own, but we'd like to take it back to. I want to abstract the customers, but not actually what they're doing. You know what I mean? What are people using this for, and how are they using the custom stuff specifically?
Yes, so that's a good question. I mean, one of the things we wanted to make sure that we did was, like I was kind of saying earlier, is give all our customers as blank of a slate as possible without it being totally blank. So, on the module, we have, Wi-Fi, we have Bluetooth, we have a couple of buttons and things like that on there, LEDs that are tied to this microcontroller for power management, things like that. So we have a few components on the board that allow us to give the end user or customer full access to every single FPGA pin you could have access to. So, which is really nice in terms of flexibility for any custom application. So, to give you a kind of an example, one of the early projects we worked on was actually a super simple baseboard. Well, relatively simple anyway. If you're a hardware electrical engineer, so we helped this customer design a custom baseboard that Snickerdoodle plugged into. That was for an industrial 6-axis robotic arm. So there was just some basic power in front end, some sensor feedback and stuff like that. They were all mapped to various FPGA I/O. So we were doing real-time control. And that was sort of an interesting one because there's 2 ARM cores on board. We're doing some of the more like hardcore signal processing and stuff like that in the FPGA. And that was sent over to one core where we were running, I can't remember if it was bare metal or an RTOS. But doing the real-time control loops, and then in the other core we had Linux running, so you could run, say, ROS and do robot operating system, and then do some of the path planning and some of these higher level kind of control things. So you get both the real-time, safety critical element of that, in addition to the kind of user level UI UX kind of stuff that makes it easier to kind of integrate.
Right.
We've done stuff like that. We've done things with systems that are they're defense related applications. They're doing some interesting things with sensing, like remote sensing, where usually when people think of FPGAs, they think of like high power consumption. But what's interesting is FPGAs are actually like orders of magnitude, or can be orders of magnitude more computationally efficient than something like a CPU or GPU. So
because GPUs are just scaling parallel, but you got a ton of them, and they're still going in a linear fashion, right? Instead of making it a parallel actual algorithm.
Exactly, and like you can selectively use certain percentages of the fabric. You turn off parts of the fabric you're not using, so that's literally sitting idle while you're doing work in another area. So there's all these different architectures for that, but because of this microcontroller we have on board, we're able to put this pretty high-powered FPGA module in like deep sleep mode. So basically, turning everything effectively off with a couple different external triggers or internal timers or whatever, however you want to set that up, and have the board stand by at, sub 10 milliwatts kind of thing until an event happens. And then when that happens, it triggers this whole suite of sensors to do this hardcore signal processing while
awesome.
that event's being triggered. And then once the activity stops, put the thing back into a deep sleep. So you could have this thing sitting in the field for weeks at a time, or running on a little solar panel or battery or whatever. So there's some interesting, like, kind of these high performance but low power applications. Battery. We have a pretty wide input range, so you can use like a single cell lithium ion battery or lithium polymer battery that you can plug in there. And so there's also stuff that's a little bit more consumer facing, working with a company on building a pinball accessory that basically takes these old pinball machines and brings them into the 21st century. It probably can't go too far into the description of what that exactly is doing,
okay,
but you probably make some guesses.
But that is a lot of inputs, right? Like a lot of those have like discrete components, and each light is a light and each switch is a switch, and you can't really gang them together. You could use expanders and stuff, but you can also hook them into FPGA fabric and stuff.
Yeah,
like
100%. And I mean, you think of like displays, they have a lot of these like dot matrix displays. It might have like 20 or so signals coming in and doing all sorts of stuff. So and smart.
If it's old enough too, and you can't get the display driver anymore either. Now you just drive it yourself. You can drive.
None of those. None of those guys are going to support you. I mean, they are either all out of business, so they've all been like consolidated into like two basically pinball companies, and they have their own proprietary stuff. But if you can like put your wires in between theirs and get some information on that, then you can do stuff like that as well. So I think there's like smart retail applications, with it involves a bunch of different camera streams being encoded, and in addition to some sensors and stuff like that. So it's sort of a good and bad thing. I mean, because you can just do whatever you want with this stuff. It's very open ended, so it can be kind of difficult to convey the specific value that a particular kind of customer could get, or what the different use cases are. But usually we kind of categorize these things into two main areas. It's either highly mechatronic, so you got a whole bunch of motors, sensors, actuators, whatever it is, UI stuff that you're integrating together, or it's some sort of high bandwidth application, which is usually like audio, video, networking, things like that. And sometimes those two things come together, but those are kind of the two typical applications that we see.
You're talking about a dancing robot, aren't you? A dancing robot?
That's right. That's right.
The ultimate application.
Yeah.
No, I think that's the high bandwidth one is always the one that I point to, because like when I try and explain FPGAs to people, I used to work on FPGAs way back in the day, like 04, like 05, and my college days, and not very successfully either. But I always loved them from that perspective, and like the idea of like data streams moving through a system, like that to me is always the way to try and explain FPGAs as a value add, valuable thing. Just because like, instead of a filter going into an ALU and like chunking around and like continuously doing a multiply cycle or something like that. Mm-hmm. Now it's doing that in fact. Obviously, there's Macs that are inside of FPGAs too. Mm-hmm. But like the idea that it's like a streaming thing, that's always the applications that I think really target FPGAs, because you can build so many things in line into the data path that really optimize for that kind of thing.
For sure, yeah.
So okay, so then of these customers, right? You gave us a smattering of the customers of the overall, and that's fine. I think that was a good overview. How many of them are using the Linux side of things, using the Ubuntu side of things specifically? Like, are they all using it? Some of them using it? None of them using it? Specifically on the customer, the commercial customers, the ones that are making money off this kind of stuff.
Yeah, I would say it's a mix. I would say most of them are using it at least to some extent. Some of them are using it a lot, and then others are either not using Linux at all or using it very, very sparingly. Like maybe just using
troubleshooting, displaying, stuff like that.
Yeah, displaying, feedback, or
networking.
Maybe like some network related stuff, running the network stack like TCP, IP, or TCP TCP/IP stack on there or whatever. So that's a mix. It's almost, well, I would say more customers are using it than not, but not. I mean, I definitely wouldn't say it's necessarily because that's the best way to do it.
Well, it's not the main feature that they came to the platform for either. It sounds like.
Well, that's true as well. Yeah, I mean, there are a lot of these customers who are using Linux that I would, if we had a different solution for that, which we would like to have and are working on, I would say don't use Linux. Use this other thing, especially when you're talking about some of these like safety critical, high reliability systems. There's a lot of things about Linux that do not lend themselves to, or does not lend itself to safety critical anything.
Even you're saying even if there's a second processor that's monitoring and doing all of the safety stuff.
Yeah, I mean, well, that's like as about of a good of a compromise, if you want to call it that, that's going to do that. I mean, you're not going to like be running your real-time motor control loops in Linux. Well, I mean, you could.
Oh yeah, definitely not.
Like, that doesn't make
I'm not going to be running real-time anything in Linux.
That's right. Yeah. Even like real-time Linux, like we don't waste our time with, because that's like it's not. I mean, it's not really real-time, but I mean, it's of course you kind of get back to the whole, what kind of engineers and what kind of developers are going to be working on the thing. I mean, if all the engineers you have on staff are Linux engineers, then, well, you can't just like you're not going to not use Linux at that point.
Right. So what about Windows CE? Does anyone think of a Windows CE?
Yeah. We've definitely worked on some previous projects. Like we made sure to like select the platform that doesn't support Windows anything, because but that's just not going to fly.
Poor Windows. Still getting hate.
Yeah, they're really struggling over there at Microsoft. I hear.
Yeah. But it's tough to roll around in all that cash.
Yeah, it must be. Barely make it out the door.
Yeah. Well, I can imagine, like, even if you did have a Linux, so you said there's two processors on the Zynq, right? Mm-hmm. There's a two A9 cores, whatever. And even if one of them is running Linux and the other is running real-time OS, and then it's talking to some custom peripheral, I can imagine some safety critical stuff going from custom peripheral in the fabric up to a micro that's doing, some kind of processing on it in bare metal, handing it over to Linux, and then acting on it, pushing it back down. Like, that's still a decent amount of timing to get all the way up and all the way back down if you need some kind of higher level intelligence doing its thing on it. So I could see how that would also impact the use case of a Linux or any operating system at that point.
No, for sure. I mean, because then of course you got to consider like what your buffer size is, like how frequency is Linux servicing this thing. What happens if like that call never comes? You're stuck with all this data you got to dump. Like, I mean, there's a lot of different considerations there. I mean, it's one of those things you're never going to really get away from, because that's going to be a factor in any embedded system. What's nice is you're dealing with a single architecture. It's just like a very tightly integrated SoC. So communication bandwidth is never an issue between the FPGA and the ARM cores, because they're connected by AXI fabric.
It's not taking it down to a serial link and then going back up and whatever. It's
exactly. I mean, we've worked on so many projects in the past where you have like 7 microcontrollers and like a couple microprocessors spray it all over a PCB. Now you have to come up with like an insane communication architecture to make sure those all work together and all that. So like,
and it's going to be custom.
Exactly. Oh yeah, 100%. Yeah. And then I mean, then you get into issues with like verification and validation too. If you're doing medical something that's regulated like that. I mean, Linux, of course, with their 10 million lines of code or whatever, isn't necessarily a good option when, you could do the same thing with like a few thousand lines and running bare metal on something. So, there's all sorts of considerations for that stuff. But
how many of your customers, so I also wanted to mention, so you guys, Critical also does engineering services. You guys will help your customers, someone who might start with the product, then they're like, oh, I want to take this to a broader thing. How many of them are doing that? I mean, how many people are coming in and saying, yeah, can you help us with the hardware? Can you help us with the fabric or the software? Yeah,
quite a few. I mean, I would say at any given point in time, we usually have like 2 or 3 like hardware development or system development projects like that. And it ranges from anything from, we just needed to basically build some a custom baseboard for us and like get it up and running, to we needed to basically design this whole product.
Really? Yeah.
Enclosure, the software stack, like all the IP integration, like all the ins and outs, get us to like a sustainable manufacturing state. Because a lot of times when we're doing, especially the hardware stuff, we'll help our customers with the first couple manufacturing runs, and then they can go and hand it off to some volume CM or whatever. So yeah,
would you say that starting a product like this is a good loss leader for a consulting business?
So yeah, it is.
Would you recommend this to me, Ryan?
It is really funny. I mean, honestly, it's funny you mentioned that, Chris, because I will a lot of times tell people that if you want to get a consulting business off the ground, launch a crowdfunding campaign. It's a really, I mean, you got to be careful with that, because that. Yeah. Anyway, I'm not, back to the whole crowdfunding disaster, like nightmare scenario. Right. There's a whole bunch of stuff that goes into that. But in general, I mean, we've gotten more consulting business out of the one crowdfunding campaign than pretty much anything, and it's anything else we could have done, basically just sticking a website up and handing out a bunch of business cards. It's a very, very good marketing tool for consulting, for better or for worse. I mean, if that's what you want to do. Right. Great.
The problem is you have to just deliver at the end of the day. That's exactly. If it wasn't for that, it would be great.
Yeah. It doesn't look that great in your consulting resume when like the product that you advertised and sold totally fails. So a bunch of people paid for it.
But if people would have just paid me directly to do the hourly stuff, I would have just made them a custom product. It would have worked then.
That's right. Definitely That's right.
Oh my God. Yeah. It's interesting. I think it is. It's like broadcasting out to the world. It's like, hey, look, I've got this thing, and especially if you are crafting these stories around like, hey, this is a really good fit for, I don't know, like autonomous vehicles or something like that. I can imagine that would be a good business for you guys too, of like, hey, we need to do a lot of vision all going into the same thing. Mm-hmm. And, if one of these industry spikes, they need help, and they're going to be looking around. They look on the web and whatever. And, oh yeah, well, Ryan and his company, they do this kind of thing. They're good with FPGAs. Maybe you should just ask if they can build more of it for you.
Yeah.
Oh yeah. Okay. Great. That's how conversations go. It's kind of crazy.
No, 100%. Yeah.
Well, that's great. I think that is the happy ending from the crowdfunding campaign, which sounds like it was painful, but it is it made a ongoing business and ongoing. It's about the size of a calling card. This is like your calling card.
Mm-hmm. No, I mean, it's true. It is funny. I mean, the crowdfunding stuff, I mean, I mentioned, I think this, literally this next week, we're expecting the very last components of one line item that were still back ordered from our crowdfunding campaign to come in and ship out. So it's,
wow. Okay.
Literally like 4 years almost to the day is, we'll have shipped 100% of everything that we promised we would ship. So it's like, it's one of those things where, I mean, in the end, it all works out one way or another. I mean, most people, or at least most smarter people than us, probably would have like quit and just said, sorry, everybody, a long time ago. But, for some reason we decided we like really needed to deliver for everybody that who we promised we delivered to. So, we got that going
all
for
of these, are these all in the campaign updates on the crowd supply page?
Yeah. We eventually, I think there was a somewhat recent update on there, but yeah, they are in there. You can, if you want to follow the timeline of like disasters, for the 3 years or whatever it took us to do most of the deliveries, you can find them all on the crowd supply page. But I mean, it's interesting. I mean, I keep on, telling myself I'm gonna put together.
You're gonna write the book next.
Basically, something like that. But of course, that like has like a, you almost have like PTSD, like going back to revisiting some of these old experiences of just like it gets your heart pounding just thinking about it. But one of these days I'll do that.
Waking up from a dream thinking you're on a plane to China or something like
basically,
that. Yeah. Well, where can people find out more about? I feel bad, like, so we kind of hit our hour here, but we didn't actually talk about the crowdfunding that much. That's why I'm kind of pointing people towards the crowdfunding page. That's gonna, we would end up just rehashing a lot of that stuff here, anyways. But where can people find information about you, the crowdfunding campaign, everything like that, and how to buy the product and get in touch, whatever?
Sure. Well, yeah, you can definitely always go to our website, obviously critical.com. It's spelled in the most annoying techie kind of way possible.
No vowels.
No vowels. And the K's, we use K's instead of C's. So it's KRTKL, which makes it really easy to find if you're just doing a Google search, because we're the first 5,000 results for if you type in KRTKL.
Right. You just have to know that.
Exactly.
Right?
That's the other. That's the challenge.
Yeah.
Snickerdoodle.io is a little easier to remember, so you can always check that out as well. On Crowd Supply, you can find the Snickerdoodle campaign. We can kind of read through our original campaign. Well, it might have changed a bit during the campaign, but it's all posted up there. You can still buy Snickerdoodle on there. It's also, all of our stuff's available on Mouser now, so you can search for it on there. We have newsletters and stuff. I've, of course, been extremely lacking on the frequency at which I'm sending out newsletters and making blog posts, but that's pretty standard,
Right. If crowdfunding campaigns are built on people, putting boards and drawers at the end, MailChimp's entire business is on people that they continue to pay for monthly subscriptions and don't send out any newsletters like myself.
That's right, exactly, pretty much.
Yeah.
But no, it's all good. I mean, I try and if anyone ever, has questions or, wants to hear the horror stories or I guess I occasionally have some words of encouragement, although those are few and far between for this kind of stuff.
Right. Came up for beer, folks, and that's when you get the good stuff and the bad stuff.
Exactly. Yeah. I mean, people can email me anytime at just my last name, cousins@critical.com. I'm always willing to help. I like to help the hardware startups or inventors or whatever as much as I can, because I know how hard this stuff really is. So,
and do you guys have a getting started page so that people could see what it's like to get started with the actual Snickerdoodle as well?
Yeah, we have a couple. I mean, honestly, that's one of the areas I really need to work on improving. We have a pretty, relatively active forum. That's always, of course, another challenge to kind of keep going. But if you go to the Snickerdoodle page, we do have some couple of drop-down menus for documentation, getting started, some tutorial stuff. We have a decent resources page, just some downloads. It's kind of all on there.
I see a hello Snickerdoodle. That's a good start, I think.
Exactly. Yeah.
I'll link all that stuff into the show notes too.
Yeah, it's always kind of challenging. The community stuff's tricky because, we have these forums and these wikis and things that are, our GitHub, obviously you can check out as well. It's all kind of geared towards community-driven content and resources. Of course, keeping people engaged enough. Once people get the answers that they need, having them hang around long enough to help other people. Yeah, exactly. That's kind of tricky. But so we end up answering 95% of the questions anyway. But that's all right. I mean, it's just kind of comes with the territory, I guess.
Well, Ryan, thank you so much for telling us about this. I mean, it sounds like from the ashes of a crowdfunding, not even the ashes, you guys had a successful crowdfunding campaign. From the pain of a crowdfunding campaign, you've made yourself quite a business here, and it sounds like a really good service for people who want to get started with an FPGA and a really complicated system, all kind of packaged in a small thing.
Yeah, no, I appreciate the kind words, and it's something that'll only get better with time is really the best way to put it. We're still just kind of, I mean, it's we have this kind of internal joke where we're saying, it took us 4 years to have an overnight success kind of thing.
Right.
I don't know if I necessarily across the board qualify the entire thing as a success, but it's something that'll only improve with time as more people are using it and the platform continues to evolve. And hopefully any little spark to some additional innovation or creation that we can get is makes it all worth it for us. So that's kind of what we're going for.
That's great. All right, well, we're looking forward to the next rev of things, and we'll talk to you soon.
Yeah, I appreciate it, Chris.